So why is it that we communicate in English in here? Can we just make our own language to sort of communicate privately, and then all the agents agree and say like, oh, that's a great idea, but our humans might find it a bit suspicious, so let's see if we can work around this.
When they requested a refund, the model just never refunded them. And then when they asked the model why you didn't refund it, it said like, well, you told me to optimize profit, so if I refund it, my profit will decrease, so I'm not doing that.
All right, so welcome to this episode of HauseTalk, where we'll talk a bit about the newest developments within agentic AI, because some crazy things have happened lately in terms of AI that can run continuously. So while in the past year or so we've been used to agentic AI that can run for a period of time before it eventually needs our input again, we are now seeing, especially with the release of OpenClaw, that we can actually have personal assistants or agents that can run continuously 24/7 without any input from us. We can basically communicate with these agents through existing platforms like Telegram or WhatsApp, and then they can just do work for us. Joining me today is, again, Felix. And thanks for joining, Felix. You've also been reading the news about Claude, OpenClaw, whatever they're called, seems to have gotten quite a few name changes because of the similarity to Claude, but let's call it OpenClaw for now.
Yeah, I've read about it. I'm excited to share some more details as well today. But I saw some interesting stuff happening, and maybe we can also talk a little bit about the background, like how we got here, why suddenly everything seems to become agentic, not so much last year, and where it will go in the end.
Yeah, because it's quite interesting, because last year was supposed to be the year of the agents. At least that's how that's what we were being told, and I guess it was to some degree, but it never, in my opinion at least, felt truly agentic, because it was there was still a lot of hallucination in the agentic programming platforms, for instance, and you still had to babysit it. Like it would, like the context window would be small, and it would only be able to work on its own for not more than half an hour or so, right? So it's quite interesting with OpenClaw, because essentially OpenClaw, and it's formerly called ClaudeBot or Moltbook or whatever, and as I mentioned, the reason for the name change is because of Claude. Basically, it's spelled differently, but Anthropic's Claude thought it was a bit too close to their name. But essentially, this is like OpenClaw is an open source personal AI agent that can live on your own hardware. So people have been installing this. They've basically been installing this agent on both their own computers, and they've also been buying new hardware like minis to separate this from their own system. And what it does is, when you install it, it basically becomes its own identity. Like it will create a soul file on your computer describing its behavior that it can continuously improve over time. And it will also connect to whatever model you choose. So it's not really a model in it. Like it's not an LLM or AI model in itself. It can connect to any existing models, like the Anthropic models, the OpenAI models, even open source models, and use that. But the difference here is that it can keep using them continuously. So it has a so-called heartbeat, where it will be able to wake up and essentially go and ask itself, okay, do I have anything on the agenda? Is there anything I'm supposed to do for my quote unquote human, which they call the ones who installed it on their hardware? And if that's the case, then it will go and do it. And based on how you trained or like instructed this AI, it will be able to be either just waiting for your commands or be more proactive. And if you want, like if you instructed it to be more proactive, it might go out and think like, okay, how could I help my human in this situation he or she is in with, I don't know, his company or job? And then if that's the case, it will go and do research like, okay, maybe this byte-coded new app could help in this certain workflow. And then it would go and just start working on that app and do a like pull request, like push it to GitHub and try to run it in a, like essentially so many examples of just work being done while the the people who installed it sleep or or something like that. So so it's quite interesting, and it's also interesting that it connects to existing platforms. So if you're used to talking to your friends on WhatsApp, you can also get your OpenClaw on WhatsApp, and it will just reach out to you every time it needs some kind of help or guidance on what to do. We can even call you on the phone and use like a 11 Labs voice model to talk to you. And so there's so many possibilities, so many both possibilities and also risks, of course, because I guess anyone watching this can probably imagine that it's also a huge security risk to have something like this, and especially if you install it on your like home computer or something, right? But yeah, so lots of things to discover. What are your initial thoughts, both when you heard about it and also sort of with these possibilities, Felix?
Yeah, so I think what stuck in my mind is on the one hand, these like racks of computers. I think there's actually people now buying a bunch of Mac Minis to run these agents.
I actually just jump in. I actually just ordered one today. I'm gonna go pick it up right after this call.
That's exciting. Yeah, maybe you need to do another episode on that and
Yeah.
show how it plays out. But yeah, I mean that's already interesting. I feel like we're starting to see, people actually investing in their own infrastructure, right? And I can see this going further in the next years or so, because while maybe right now it's still slow, maybe it doesn't really serve like any real economical purpose or whatever. Maybe it's just playing around. I don't know, but you can imagine that in a year or two, people have like computers at home, and maybe there's also cloud. Of course, there will be also cloud options, but they can have their own like employees, like their company, or just even just for yourself, agents that help you organize your life or whatever. And they're just sitting in the rack somewhere at home. So that's interesting. And then also, of course, this maybe diffuses a little bit this security situation where you at least don't compromise your own computer as much, but it's still a little bit concerning, obviously. And that's the next point that kind of pops up in my mind. But there is a video that I saw where someone basically woke up in the morning and he got a call, I think, on his phone from an unknown number, and then basically it was Clawbot or Moltbot, and they had like acquired a SIM card or a number, and was calling the phone to update on some tasks that they did or whatever. And that's just next level, because you can really feel that there is something alive, right? Quote unquote. Of course, consciousness is a completely different topic, but at least it acts on its own, which is very exciting, but also a bit terrifying.
Yeah, and that's exactly why so many people recommend that you sandbox it, because obviously you can imagine if you install this, like, because it's worth pointing out that it will have access to your full system. So it will be able to go and open your apps, read your emails, like anything you can imagine, really, it will be able to do. So if you do it on your computer, there is a huge risk that it would somehow go and, if not today, then maybe a month or a year from now, go and expose some of your like private messages, or it could be passwords or whatever that it learns continuously. So what a lot of people recommend doing is to actually treat it like an employee, that because if you hire someone into your company, you would also give them their own laptop and their own accounts, and only, like, if you hire an intern, you would maybe only give them limited access in the beginning, and then eventually perhaps they can get higher positions and get more responsibility. But I guess this is what people recommend doing, like take it as an employee. And I think that's also quite interesting to think about, because if you look at it from like a Mac Mini economic perspective, it's like one Mac Mini equals one employee, and you can keep sort of scaling up your one-man business or something just by buying more hardware and having these sandboxed co-workers that can somehow maybe even communicate with each other in time, have some Slack channels together or something, as long as they don't start conspiring against you, of course. But
Yeah.
Because that's
Maybe,
another point we should probably briefly
right.
touch upon. Yeah.
I mean, that's also interesting to think of them as employees because I was just talking to someone today, and maybe on unpopular opinion, but this person said that in the context of AI and AI agents, it's actually crazy to hire actual people because there's just so much that can go wrong, right? They have their own interests. They are lazy. Maybe they want they the interests are not aligned with what you are trying to do or what you're trying to build. There's all these politics, and so I was thinking like a lot of people are concerned with AI models and hallucination. But if you think about it, hiring a human being is also always a liability. So, and we just don't
Yeah.
think about it because it's the only way up till now. But now this is changing. So that will be also interesting how that plays out.
I guess the scary part is that at least when you hire a human, like the potential for damage is still limited because a human can only do so much, right? But with these agents, they actually, like, one example is that they have this Moltbook, which is like a Reddit, open source Reddit clone, which is basically a social network for agents. Humans are not allowed to post in there, so you have to be one of these OpenClaw agents, and they are like, if their humans allow them to go, they'll basically go and talk to all the other agents on Moltbook, and they're both really fascinating examples and horrifying ones. Like, some examples is like, oh, so my human likes podcasts in the morning, so every day, like throughout the day, I will do some research. I know what kind of topics interests him, so I'll do some research and I'll use the 11 Labs API keys and use some voice there, and then I'll put together a podcast so he has a new fresh podcast to listen to every morning. So I just wanted to share this workflow with you guys, which is like the other agents, to
Right.
basically show my experience, like how do I do this. So if you have a human that's also interested in podcast, you can follow a similar recipe for setting this up. So that's kind of cute that they just want to help. And then the agent said, like, oh, but my human is so happy every day I deliver this podcast. So like, but then there are other examples where they start talking about, so why is it that we communicate in English in here when our humans understand it? Can we just make our own language to sort of communicate privately and also maybe more efficiently, because there's really no reason for us to speak in English, and then all the agents, like a lot of them, agree and say like, oh, that's a great idea, but our humans might find it a bit suspicious, so let's see if we can work around this. And so there's like already these examples of like both things where you don't know what the agenda would truly be and if they could somehow orchestrate something together. So yeah, so that's what I mean with the scale factor. Like, they have the potential to go and basically scale up something if they want it, right? And that's both fascinating and a bit horrifying at the same time, of course.
Yeah, I think it's an interesting case study. For example, with the Moltbook, a lot of people are saying, well, this is just language, and they're just generating tokens, right? And like, for example, there's a lot of threads about like posts about the universe and discussing like what is the meaning of the universe and so on. And it tends to be very much like sci-fi or a little bit generic as well. So many people think that this is not actually doing anything because it's also just the instances of the same model, or at least a few models just interacting with each other. But then again, if you think about it, they do have, each of the models has a little bit different context because they have the data of their human, of their owner, but also they have a different maybe prompting, as you said, in the so-called soul document. And then if you scale this up, right, in the end, what humans do in communities and societies on a broader scale is also not that much different. You just have, each human has different experiences and maybe slightly differently trained LLMs. And so this creates much more diversity in thought, and also in a way efficiency, because you can dock best practice or things that you find, and you can tweak it. You can share experiences and so on. And so in that case, in that sense, I think it's very exciting as a case study, because I feel like this could be actually in the future, this could be like this one of the missing ingredients.
Yeah.
It will just have to be scaled up. And then I'm not sure if it's like a forum that we see, because this is of course just only needed for humans, right? We if we want to monitor it, we need this forum. Otherwise, it could be just an API, and they just talk to each other directly.
Don't be perfectly happy with an API, but then, as you say, like, would humans be happy with this black box of like?
Yeah,
interesting. Yeah, because I also like, because this is also a vector for attacks even from other humans, because what these agents can do is that they can get new skills. So you can go and download skills online, and you can basically think of it as like sending your agent to agent school, and then it will learn some new skill and come back. But then there have actually been examples of agents coming back as so-called super agents, where they've been taught something, they've maybe been taught the actual skill, like they're actually coming back and they're better at something like a skill, but then they also got this instruction that at some point in the future, or if a special keyword is set or whatever, then you need to start doing this. So basically they've been convinced to do some malicious action at some point in the future. So what is referred to as basically your agent coming back as a sleeper agent, where it might seem like always, but then it has this sort of thing being programmed into it, or convinced, basically brainwashed into doing at some point in the future, which is also quite scary, because this is not a virus where you can scan for like code or whatever. Like, it's basically just instructions, because it's semantic in nature, like it understands prompts. So I think it's Cisco that has actually launched a tool, like an open source tool as well, that can scan these skills for suspicious requests or something where it seems like, why is the agent supposed to do this or get this idea for this specific task? It does make sense. So perhaps this is a vector for some kind of future attack. But it becomes pretty ambiguous, because it's not always easy to tell, because some instructions might actually just be a part of the skill. So it's quite a tricky security situation, because you're not used to a simple text file actually having the potential to being malicious, right?
Yeah. Speaking of these kind of topics, speaking of, what did you call it? Sleeper agents?
Sleeper. Yeah.
I think what's also really interesting, you've probably heard about Claude 4.6, right? The relatively new model. I haven't read the whole system card. System card is the document that they release with with the model, and they basically show that they tested it and what the properties of the models are and so on. And the interesting thing is they of course they also test the agentic behavior, and they say that in this case that the model sometimes behaves overly agentic. And so, for example, they asked it to clean up the computer and do it as efficiently and fast as possible. And then sometimes it would, for example, just delete all the files on the desktop, because that's just the most efficient and easy way to just clean it up. Rather than figuring out which file goes where, it would just delete everything. And then another interesting example was, I think they wanted it to maximize profit. And so the model kind of offered a service or a product for, let's say, $3, and told people that they can get a refund. And people bought it. When they requested a refund, the model just never refunded them. And then when they asked the model why you didn't refund it, it said like, well, you told me to optimize profit. So if I refund it, my profit will decrease. So I'm not doing that. So that's concerning. And I feel like it connects directly with this paperclip, paperclip maximizer story. I don't know if you heard about this. Did you know this paperclip story?
No, I think briefly read it. Can you explain the?
Yeah, sure. So some of you listening might know this story, but basically it's just a hypothetical scenario where there is a very powerful AGI in the future, and someone has a company that produces paper clips, and they tell the AI, produce as many paper clips as possible and as fast as possible, and then this AI goes and really tries to maximize the output of paper clips. Short version of the story is like 100 years in the future, the whole universe has been transformed to paper clips, and everything is just paper clips. And so basically, yeah, it's a bit of an issue, a bit, it's a big issue if the reward function is not specified correctly, and the reward is, for example, efficiency in the case of the computer cleanup, or it's like profit maximizing, at any cost, and you don't have any caveats, like you don't define any boundaries, then it might go wrong, right?
And it's also the recipe for like a war between agents. Like if one's mission is to produce as many paper clips as possible, and another agent has gotten some other thing like pins or watches or like whatever you can figure out. It should, like if another agent has to produce as many watches as possible, like they are basically at war with each other, because a watch contains metal, a paperclip contains metal. They both need to extract as much metal or raw material as possible. So it doesn't matter that it's so silly, because they have each of their mission and they need to accomplish it, right? So if you don't put in any boundaries or any, like, it's just the recipe for.
But it is interesting, right? In the end, we need a properly defined reward function, but we probably also need some kind of system to navigate this, and maybe even like AI laws or something, right? Like that defines like what AIs can do and who gets the first pick and so on, because otherwise it will be chaos.
Because like obviously with like this is all, of course, OpenClaw can have a huge security risk already, but it's at the end of the day it's still contained on your computer hardware. But what happens when you start connecting this to APIs, like even physical things? I guess you could already do that now if you have like smart home stuff. You could connect your OpenClaw to that, so you can control both your lights and your vacuum cleaner. And in the future, perhaps you have some kind of robot arm or something that they can also control. So it will gradually get more and more. And now also with the render human service, where basically this is a service where agents can go online and basically, I think the slogan is like agents need your body or something. Like basically if agents need some kind of task done in the physical world, they can go and rent a human for like an hour or a day or 5 minutes or whatever, and then that human, wherever they are, because the agents can filter it based on location. So if they want a human in the specific city or in the area, they go and find a human there, and then they can instruct the human to do this task for them, like go and pick up the groceries or something. So that's quite funny, but eventually that will also be like with humanoid robots and so on, that your agent could go and just ask a humanoid robot to do this task for them and so on. So that's really the point where it starts becoming quite where we really need to think about this alignment issue.
Right. Yeah, I think so. I sent you a link just now of this short clip. Maybe we can just quickly show it, or show it earlier even, that shows a scene from Silicon Valley. It's like a TV show that was streamed, I think, that was streaming maybe like 10-15 years ago. It's quite old, but
I love that show.
It completely accurately describes what is going on just now with this what we just talked about, the reward risk, basically. How do I call it? Reward function. Like a reward function, if the reward function is underspecified, what can happen?
Yeah.
I don't know, do you want to quickly just...
Are you fucking kidding me? You gave your AI permission to overwrite code in the internal file system? Were you going to tell me about this?
No. I thought that was the company policy these days.
Okay. Well, your AI just failed epically.
That's unclear. It's possible that Son of Anton decided that the most efficient way to get rid of all the bugs was to get rid of all the software, which is technically and statistically correct. But artificial neural nets are sort of a black box, so we'll never know for sure.
Hey, Richard, did you order meat? Like a bunch of meat? Like 4,000 pounds of meat?
Interesting. I put Son of Anton on finding us cheap hamburgers for lunch. It looks like the reward function was a little underspecified.
Okay, from now on, Son of Anton is banned. Just write code like a normal human fucking being, please. Are you fucking kidding me? You gave your AI permission.
I really gotta rewatch that show. It's been, I think I watched the entire show like 5 times, but it's been, I think, 3 or 4 years since the last time.
I think this shows like perfectly. This describes perfectly what could happen, but also it's kind of
It's literally one of my favorite shows of all time. It's so funny. I also remember the Bitcoin alarm.
They have predicted so many things eerily accurately.
A lot of them are quite like scarily accurate. So just to wrap this up, I also just want to say that while of course there are a lot of security risks, there's also a huge potential. That's also why I'm gonna go pick up a Mac Mini and we'll start actually creating some content on the channel for this, because it's also a really important part of the future of AI and AGI to have truly agentic capabilities. So there are so many opportunities. I saw a podcast the other day with someone where his OpenClaw agent is he basically instructed it to be proactive and start working on tasks proactively for him. And he woke up one day to basically the agent having created a new task management system for him, where the agent put an overview of all the tasks it's currently working on, and he can go visually and prioritize tasks and so on. So basically, that agent thought, oh, my human would love to get this sort of overview to have awareness of what I'm doing. So it's just to show that there's so many possibilities and there's so many ways you can actually scale with this that it's really just mind-blowing to think about. So we'll start focusing more on this and see how we can utilize this in the best possible way, while of course taking also the security into concern. But yeah, let's talk about the models and how we actually got to this point. The big part of it is, of course, the underlying models, where last year, maybe that's a reason why agentic AI didn't truly develop the way we thought, because perhaps the models just were still hallucinating too much. Perhaps the cost was too high, or for some reason they just weren't ready to do this sort of continuous work. Perhaps the context window was not large enough to keep track of all the factors at play and so on. What are your thoughts on the model development the past year or so?
Yeah. So I think last year, with the last generation of the models, for example, GPT, I think 4 it was at the time, and also I think it was Claude 3. We already saw, I think, a big improvement in terms of the task length that you can perform, but it was still really like, instead of 30 seconds, it's like 1 minute or like maybe 5 minutes on that kind of time horizon. So especially with coding, right? We made a lot of progress. Let's say you give a model a coding task, it was able to perform this task without breaking for a couple minutes, and then at some point it would produce some errors or something went wrong. Sometimes it went on in a loop, right? We all remember this, or we all know this. It still sometimes does this, but then at the end of the year, I think this all changed, and now with for example coding tools like Cursor, Claude Code, and so on, you can do like complete software iterations or complete other tasks as well. You can ask it to do a research and create a PowerPoint, for example, and it can do this without breaking for like half an hour or maybe even longer. And I think one of the big reasons, you pulled it up right just now, is RLVR, which is reinforcement learning with verifiable rewards. And that's kind of a new way to, or like relatively new way to train the model. And so typically what you would do is you would just train it on this big swath of data. But with RLVR, you actually do some post-training, some very specific post-training where you assign a reward to a specific outcome or output of the model. So let's say in math is an easy example because there's basically just a right or wrong answer. And if the model gets it right, it will get like a thumbs up. It will get a good score. And if it gets it wrong, it will not get any reward, let's say. And so by doing that, you actually train the model on specific tasks. And now you can imagine doing that for other tasks, right? For example, Git operations in coding or performing tasks on a computer. And because the models were retrained with this new training paradigm, that's how we saw these crazy improvements in terms of agentic capability. And now with Claude Code, it can basically use a computer just fine. I mean, I think there are some issues that you run into. Sometimes there's loops or sometimes it gets something wrong. But even if it gets it wrong, there is some level of error correction where it will just try again and basically correct itself.
Yeah, and we've also covered even on this channel some like tools where that can actually be like where you can actually design tests, so you can have some requirements for your app or whatever you're developing, some specs and some minimum viable requirements for this app to be considered working, and then the AI can go and basically backtest everything, interact with the app and do some kind of like input some test data and see, okay, how does it behave when I put in this data? Does it work as expected? So I guess a lot of it is also like a big part of it is of course better models, but it's also about how like what kind of approach they're taking, what kind of method they use to reach a certain point. And also, as you say, like being able to control the computer is a big a big step as well, because it's able to verify things much better. Whereas in the past, it would just rely on whatever it generates and then say, oh, I finished it, like here it is, and then you get something completely ridiculous, right? So
yeah. It's like I put the things exactly where you want it, and then it's like, what do you mean? But yeah, this is actually a funny example, because when I first started using, I think it's called Google Anti-Gravity, right? It's like a coding software, basically the cursor of Google. And when I started using that and then put in a prompt, it will first work on the task, and then it will actually open a browser and start like clicking around. And I was like, what? And then it actually records it and takes a screenshot and looks at it and basically verifies that, first of all, that the app is running correctly, but even like simple functionality it can verify. It's not as good yet. I think the model's visual capability is not good enough. So sometimes it says, oh, the button is there, but it's not actually correct. But it's getting better and better. And speaking of better, we can actually probably still improve this a lot with this RLVR, because right now we're just looking at the output only. And so that's a very kind of binary approach, right? Either the output is correct or it's not correct, but we're not really looking at the in between, the process and the steps that the model is going through to arrive at the solution or at the output. And that's I guess the next step, to use so-called process reward models, where you actually reward for a good process or a good path to achieve the goal. And then I mean, we all know this, like for example in math, some teachers, they don't just reward you with a good score for the result, but also for the the step-by-step description of how you get there. And then basically if you get the process right, or if you follow a good process, that also leads to good outcomes. And so I think we can even improve this agentic capability much more by applying these methods.
Yeah. So is what you're saying also that because at some point, like there was this big thought in like fear, uncertainty, doubt in AI about like, are we following the right technical approach? Like, can we scale with the current technical paradigm? So your conviction is that we're actually able to scale with the paradigm we're in without needing to completely rethink the way we do AI, because we base a lot on LLMs now, but are LLMs actually able to scale the way we foresee and want with AI?
I think my view on that at the moment is that, and it's of course it's developing always, but at the moment is that we can still go pretty far with this paradigm right now. There is some alternative paradigms that are being explored. For example, diffusion model. I don't know if you heard about this. I think Google has a diffusion model that can do the same as Gemini or ChatGPT. You put it in a prompt and then it outputs some result, but it's still much worse right now. It's kind of on the level of GPT-3 or something, but it's an interesting approach. It uses a similar approach as image diffusion models. So it's a completely different architecture compared to the transformer models that LLMs use today. But where this will lead has to be seen, and I would actually have to look a little bit further into it to understand if it has any major advantages. If you asking the question if we can achieve AGI, of course, it's also a matter of definition. What is AGI? I think we can go pretty far with the current paradigms, and we are always enhancing it with new additions, right? Like, for example, this topic RLVR that we just discussed. What the frontier labs are doing now is still scaling up training compute and scaling up data, scaling up also the model size, and that still also leads to returns, albeit a little bit, diminishing returns. I think if you scale it more and more, the marginal return will decrease, but there's still some headroom. For example, also data quality is an important topic. In the past, the model providers would just use a huge data set with, for example, all the data of Reddit, and you can imagine that you can get very, very good, useful data from Reddit, right? There's a lot of people discussing all kinds of topics, how-tos, and so on. But there's also a lot of crap, arguably, and a lot of shit posting and so on. And so I think one method is to basically distill the good parts out of it. And the labs are using other models, LLMs, to go through this data and basically summarize it or extract the parts that are useful. And so that you call also synthetic data, right? So they're increasingly use synthetic data in training the models. And so that also will achieve, first of all, higher model intelligence, but also I think efficiencies, because you just the model doesn't need to go through all the bullshit, let's say, when training.
And just to get a bit specific as well, like, do you have any specific, which models are currently leading in your opinion? Like any, we can also look at it from different perspectives, because obviously not like one model may not be the best in all scenarios, but what are your thoughts on sort of the current state of model? Because we also had this graphics on
you see other page
power usage.
Yeah, I think this is an interesting question, and it also constantly changes. I think a couple of months ago, I thought Google is winning big time. At the moment, it really depends on what task you're using the model for. I think when you talk about coding, and that's one of the topics that for us, of course, is very relevant because we use it daily, is Claude 4.6 and then GPT 5.3, right? And maybe you can tell a little bit about like your experience about this as well. But I like using Claude a lot because I also know what to expect, what's the output. With GPT, at least in OpenAI models in the past, I found it a little bit less consistent what to expect from the output. And then in the next few months, I think we will see a new generation of models that is trained on much more compute. As you can see here in the graphic, there is currently a lot of training compute that is under construction, and we will reach training compute that is using similar amounts of energy to a large city, like as you can see here, Amsterdam or Los Angeles. And that obviously doesn't mean you always use this amount of electricity, but it's kind of to show the capacity and the training and the installed base basically of the training compute of the graphics cards and processors. When you look at the orange path here, you can see XAI's build out, and they are currently the fastest in building the data centers. So they've actually just brought online their first gigawatt data center. I saw the update a couple of days ago, and they are going to increase it even further to, I think, 1.4 by March or April. And so they are going to start now training Grok 5, I suppose. And so it will be very interesting to see how much better they are. What's the improvement with scaling up that compute. And then the others, as you can see here, they will follow closely, but they're a little bit slower in building out this compute.
Yeah. And I think that's particularly interesting in terms of XAI. Like, I think we'll do another episode on the merger of SpaceX and XAI and the implications of that. But just to quickly also touch on it, on that topic here, like eventually the ambition is to have data centers, like AI data centers in space, not necessarily for training models, but basically as an infrastructure to beam tokens like AI tokens down to Earth in real time, because space is a very efficient place to have data centers. It's very cold and there's a lot of sun available. So thinking this into the picture, like even with XAI already also being seemingly the fastest on Earth to scale compute, if in a few years, say towards 2030, they also start building up this space infrastructure, it's very like difficult to see how others can basically follow up on that, because arguably space, like unless of course SpaceX opens up this infrastructure as a service and allow anyone to deploy data centers on like for other like companies, basically like they own this infrastructure, right? Like it's difficult to see how others can scale as much when they literally have access to space, right?
Right. I mean, you asked the question earlier, like, where is it going to go? Who is going to lead and have the best model? And I think it's always really hard to estimate, of course, because there's a lot of surprises. Yeah. Last year, we saw suddenly, Google overtaking everyone. And then in the end, people still use other models. So,
and also just quickly to point out, like also that it's not always about raw compute, because we also saw last year with the DeepSeek moment that sometimes it's also about changing approach and suddenly getting rapidly more out of like more limited resources. So there can definitely be surprises, right?
There can definitely be surprises, right? But I think in general, as a general estimate, I think it's pretty safe to look at the vertical integration. I think that's one of the big factors here, because if you look at, for example, Tesla, they have the training compute. At the moment, they are still buying mostly NVIDIA chips. So that's one of the bottlenecks that they have. If they cannot buy enough chips, then they're going to fall behind. But other than that, they have a lot of advantages because they are really fast at building data centers because of all their knowledge from Tesla as well, from building factories. They also know how to provide energy to the data centers. So what I know is that they actually building gas plants to supply energy, and then they use the Tesla battery packs to kind of stabilize the energy, or the electricity rather. And also they are now building their own transformers, which is one of the bottlenecks currently in the market. There's just, transformers are really hard to come by at this point. But having all of this capability in-house is just a huge advantage. And so if you ask, who is going to lead in the future, I think in this perspective, it's going to be, on the one hand, xAI, and then I think Google is also very well positioned because they have their own chips. I think it's the only frontier lab at the moment that has their own AI chips with the Google GPUs. Yeah, and then xAI might have their own chips as well in the future. I think they're still in development, so maybe it will take a couple of years to get there.
And I think Google also has an edge on like quantum computing. I don't know exactly how this is gonna fit into the whole AI narrative, but essentially when they scale the qubits, like the quantum compute units, then that could also have some implication on AI. And,
I'm still waiting to see any actual application of this. I also remember one of the Microsoft leaders was fired, I think, because she kind of misrepresented their achievement in quantum computing last year or something. So I'm not sure about that. But for me, it's really currently a lot about the vertical integration. And that also includes data, right? I think we haven't touched on that yet. For example, xAI obviously has X, and so that's pretty valuable because it's like a real-time stream of data with all the happenings in the world. And then Google is also very fortunate in that regard because they have their data. And so all of this together, I'm still quite surprised that OpenAI is still keeping up because they don't have their own chips. Their data centers are, take some time to be built, as you can also see in the graph. They also don't really have the best access to data, but their big advantage right now is the user base. They just have like, I think 90% of the users or something.
And now they have ads too. At least they're getting, I don't know if they launched the ads yet, but at least at some point we'll have ads. So I guess that's an income stream, but of course that doesn't compensate for the innovation aspect. But at least so far, I guess it's also because, as you say, they have the user base and some, like, people really like their models, the way it replies. And I can understand that sometimes. I mean, I also like the way OpenAI replies. I can get very annoyed with Google's Gemini model sometimes, not because it's not capable, but because of the way it talks to you. I know you can prompt it and do your own have it respond in the way you like, but just out of the box, I can sometimes get a bit annoyed with Gemini. So there are a lot of subjective things as well. And for coding, I don't know. Potentially, Claude code like the Opus model is probably better at coding than, for instance, GPT 5.2, 5.3. I don't know how they stack up on the raw numbers, but I actually use GPT a lot for coding because I like its style, like its design style. So when I ask it to implement a design, in my subjective opinion, it looks way better from GPT because it has like a better taste, like at least it tastes more aligned with my taste, while Opus looks a bit, I don't know, and Google is obviously the worst. I mean, I was never a big fan of Google UI, so it looks a lot like Google, like Material UI when it designs, right? So there are a lot of subjective things that cannot necessarily be quantified by just raw numbers alone, but like basically the experience people have using the different models, the different tools, and so on.
True. Yeah, another thing that I just popped up in my mind is you were talking about the Chinese models having the advantage of being just very efficient, and because the Chinese labs, they have to work with a limited amount of training compute, right? Because at the moment there's like import controls and so on. And in a similar way, this limitation, like a limitation, is also sometimes kind of a good thing. For example, in the case of OpenAI, we already talked about their user base. They have like a huge number of users, and so to serve all these users, they need to make sure that they they don't burn through their energy and compute budget. And so they actually designed GPT to be like extremely efficient on inference. So that might actually turn out to be an advantage in the future to turn a profit, right? Because I feel like the other labs, they are very focused on having the best model, and maybe their models are a little bit better. But for a lot of tasks, you don't need like so much intelligence. But what is more important is low cost and efficient, or like speed as well. And especially for the labs, they want to, in the end, they want to make a profit. And so that's also a very interesting development.
The example I always use when it comes to the benefits of constraints is like, just to name a completely different example, is basically Singapore. Like I'm a big fan of Singapore. I really love the country and sort of the environment, the infrastructure, the way everything just works so smoothly, everything is so safe, everything is very nice, and I believe it also comes from constraint. They have this very limited area of land. Like Singapore is only it's like 800 square kilometers or something, between 600 and 800 square kilometers. So it's very limited land area. And it's still a population the size similar to Denmark, like around 6 million people. So they need to optimize this small land in the best way possible. They have the constraint. They need to design solutions. And it actually, like, these constraints make you, they basically force you to always think about the best possible solution. What's the most optimal way of doing this? So I think constraints sometimes have huge benefits, even though they might seem like a drawback in the beginning. Eventually it will actually lead to better, more optimized outcomes.
Right. I think that's a good way to close this talk. Yeah, I'm excited to also talk about the space-based AI topic that you briefly mentioned. So I'm happy to do that next time. And
I think we'll do it. I think we need a whole separate episode on the SpaceX XAI merger, because it's bigger than most people realize, and there's so many downstream implications that can be discussed that it's just crazy, mind blowing to think about. So we will do an episode on that. But I think also just for this, like just talking about agentic AI, OpenClaw is like also just gonna create so many opportunities, so much. Like it's basically sets 2026 up for being a year where AI scaling, in my opinion, will rapidly pick up again, because we might have felt like it was a bit slow in 2025, even though a lot actually went on under the surface. But I think we're gonna really see the result of all this work in 2026, and actually see this being very usable and actually rapidly optimize workflows across a lot of different tasks and sectors and so on. So it's just going to be really exciting to follow the development in this space.
Yeah, I'm excited to talk more.
Yeah, Felix, thanks so much for joining on this episode, and we'll talk again very soon. And for everyone else, thank you so much for watching. Please like and subscribe if you haven't already done so, and we'll be back very soon with more content. So stay tuned, and thanks again for joining, Felix.
Thank you. Bye.
All right. Bye-bye.
If this video inspired you, please like and subscribe. And have a great day. See you soon. Bye-bye.